Oh, like, can you see my screen?
Yes, I can.
Okay, cool. So last time we just ended on strings, and if I could open the code from the last session, what we just really did. Yeah, we were splitting, we were replacing some things from the strings, and strive to remove spaces at the beginning and ending, and that's
Yes.
a quick recap of what we did in the last week. So yeah, Boolean. Like, do you have any idea about Boolean data type?
Yeah, I know. They are the yes or no,
Yeah. Yep.
true or
That's right.
false. Yeah.
Yeah, true or false. True in kind of machine language represents one or an on gate, the gate which is open, and off means the gate which is closed, or zero basically in binary language, machine language. So in this exercise, there's we can't really play with true and false, but we could generate true and false in different use cases. Like here, if we do like 10 is greater than 9, it will just output true. If it's equal to 9, here it will be false. If we say 10 is smaller than 9, then it's kind of false. Let's kind of quickly run this to see this. Like, see, true, false, false. That's the one way where these true, false Boolean data type can be generated. And yeah, same here. Like, we can use that in if condition. We haven't kind of discussed if else statement, so we later on gonna see what that really means. But we can use a Boolean in if statement. Basically, if statement only works when there is a true. If there would be a false somewhere here, it will not go inside its body and will not run this statement, you know. And scrolling down, yeah, as I last time told you, like when we use this typecasting, like type conversion, we have seen like convert this float into integer, and it does that stuff. But if we do, let me increase that. If we do bool, can we do with bool or boolean? One, 50. Oh, we can do with bool. And as I was telling you, like if there is a string and it has something in it, then it's always gonna be true. Same goes with number and something. But as soon as any data type is empty, no matter what it is, like here we could see this. Like, see, if it's an empty dictionary, empty list, empty tuple, empty string, or zero, or it's like originally false, and we are again using a boolean function to convert that into a boolean data, it's gonna be false. But with these three cases, zero, none, and false, like in all these cases, it's gonna be false. So it's just good to remember, if anything is empty and we apply some kind of boolean conversion on it, it's always gonna be false. Let's do a quick check. If everything is false, yeah, everything is false. I guess we need to do something like this, and then let's run this, and yep, everything is false. So nothing much
Mm.
in this, but this was the only important thing to know. If anything is empty, it's gonna be false. If it has something, then it's always true. So
How did you, were you able to write print on all of the lines at the same time?
that's a shortcut. It's The shortcut is to select the and the shortcut is it's like alt. I don't know what's that on Mac, but in on Windows it's alt, and no, it's control ctrl. I guess on Mac it's command plus F2, and I don't know. if you have to on Mac or no, but that works for me
Yeah, we have. Yeah, we
on
do.
the
It's on
Windows.
Mac too.
It's like if you select something, let's suppose if I select print, all others would get highlighted. But if I also want to select them, I would just do Control F2 and all of them will get selected, and I would have a cursor on all of them. So that's a good shortcut to,
Mm.
yeah, save time. So yeah, what was next? Like variables are false, and here we have class. We don't need to really go into that, and these are kind of advanced concept. It's basically discussing the use cases of true. We can return true from a function or return false and that stuff, and like depending on the result of the function, like the returned result of the function, we can use if else statement. We're going to discuss that later, but I guess that's it for now. Oh yeah, this method is instant. Let's discuss this. So as you can see, we have like a variable x, and it has 200 store a number or an integer 200 which is stored in x, and this instance is basically what it takes two arguments. One is the data type, and the next is the no, the first is variable, or like the data which we want to check what it really is, and the second argument is the data type. So
Mm.
if I hover over this, it returns whether an object is an instance of a class of the that stuff. So basically, it just checks that if this x representing like 200 is belongs from the integer class or float class, or it could be anything, or string class. And if I do str, it will say false. But as soon as I convert this into a string, it will say that yeah, this 200 belongs from a string class. So if it's a string, it belongs from a string class. So this is also a
Mm.
good method, a function actually. This is a good function to keep in mind. Instance, and here we just put value, and here we just put data type. Okay, next is exercise. Like, I guess it was pretty straightforward, right?
Yeah, it was.
Yeah, so operators, as you know, like there are different arithmetic and assignment, and I don't know, yeah, like see ton of them. Arithmetic are basically addition, subtraction, that are related to mathematics or calculation. Assignments are when we assign, like here we use the assignment operator, which is equal, and there could be more
Mm-hmm.
than that to assign values to that stuff. Comparison is basically comparing. Here I guess we used a kind of greater than or less than equal to that stuff. Logical operator are, I guess, and let's just discuss them. I guess and or that stuff. Identity would be is or something, member in bitwise. Let's just see them. Arithmetic are like these: addition, subtraction, and for multiplication in Python we use the star sign, and for division forward slash, and modulus. Do you know about this modulus sign? What it really does?
I I know we did it in the class, but I can't remember right now.
Huh. It basically returns the remainder. Like when we
Okay,
divide
yeah.
some number with something, it just returns the remainder. Let's suppose 6 modulus 3. It would return, that's markdown. It would return 0 because that got divided. Like the
Yeah, yeah.
remainder was 0. If I do 7, we will have a remainder which is 1.
Yeah, yeah, yeah,
You know,
yeah, yeah. I remember now.
that's what it does. And exponential, this is basically taking the square
Yeah,
root.
yeah, yeah.
I guess you know. And floor division, it just gives a answer that is an integer. It does not give the answer in float. Let's try that. 44 divided by 5, it gives an 8. But if I do 33 divided by this, it simply gives me the whole kind of integer thing. But if I use a single slash, it would give me answer in decimal or
Yeah,
float
yeah,
data type. It does not kind of rounds off. Like as you can see, it was 6.6, but it should do a round off. But what it was doing, it was just, kind
Okay,
of
okay, okay, okay,
slicing this part and just keeping the
okay.
integer. It does not kind of really round off something, so that's a good thing to keep in mind. Maybe I can write the command in code. Skips the
The decimal.
decimal part and uh, returns
Oh, the integer.
rounding off. You could check for the spelling mistake later. Oh, next one is assignment operator. As we saw, like equal to, it's like kind of pretty much easy. But do you know about
Yeah.
this one? Plus equals to. Any idea?
Uh,
Uh,
I'm
Maybe you
not
can
sure.
take help from here. Okay, let's do this. Let's put a heading to Python this in the code. So okay, so to assign any value to any variable, we use equal to. That's pretty much easy. But let's suppose we are like, we want to plus something in 4. So what we really need to do is we need to take a and then plus something in that. Let's suppose I want to plus 1 in that. That's a good thing to do. That's, pretty straightforward. But let's suppose we are like, I don't want to write much of the code or something, or basically it just adds one in a, but if I again after that print a, the a is kind of, still 4. And if I need to do that, what I would do is I would say, okay, a plus 1, but answer assign the result again to this a. So basically what I'm saying initially a was 4, but you just take a, add 1 to it, and rewrite the variable a. So this time I will get a, but it would be let's run this again. It was 4. Yeah, it was 4, and now it's kind of 5. But there is a shortcut to do this. The shortcut is we can do is a plus is equals to 1. So it's just a shortcut, nothing else. You could even use this
Okay.
code, but that's a kind of shortcut. As we can see
Okay.
here, plus is equals to, it's like takes the variable, adds to that, and again, assigns to that variable. Same goes with minus is equals to, takes the variable, subtracts something, and again assigns to that variable, the same
Okay.
variable. Same for multiplication, division, modulo, division, square, and I guess is, let's see what it really is, because I don't know what it can do. A adder. Yeah, I don't know why they kind of added this here. Unsupported operation of string and integer. Yeah, I don't know why have they added, because we kind of never use this thing and this thing and this thing. I don't know, we can just skip this, but maybe we can try this thing.
I can,
Maybe it's
yeah,
good.
try them on my own.
Yeah, because that's giving error. If it's giving error, then I guess that's not a good. Yeah, same here. Like, I never heard about this. Like these things, which they like these four steps. Maybe it's useful, but as you can see, it's not running. I don't know where they really got this from. But next operator is like comparison operator. It just, makes a
I know
comparison.
that.
Yeah, the result is in Boolean, true or false, equal to, not equal to, greater than, less than, greater than equal to, or less than equal to. I guess you know
Equal to.
about, like, when we do
Yeah.
like, oh, it should be like include this number, and see that it's like we also need to include the number which we are looking for. Okay, so logical operator. These are the operators to combine two different comparisons, basically. Or, yeah. Like, do you have any idea about them and or not?
Yeah. No. No.
No. Okay, let's see that. Let's add comment here, Python logical operator. Okay, so let's suppose we are in a condition where we are, what we are doing, I don't know, we just want a number which is which a is a number that should be greater than uh, 20, but should also be a should also be less than uh, 50. So we specify the range. A must be between 20 and 50. And
mm,
in like here we are just doing like two things. For this thing we will get a separate answer, and for this thing we are gonna get separate answer. But if you want to combine them, what we can do is we can just use an and operator just between them. Oh, and or and, yeah,
mm,
and the and, not this one. And the end. What it will do, it will kind of take this result and this result and combine the result and that stuff. And for and,
mm,
both the should be true. The answer of both these conditions should be true, and if that is like if both are true, then it's gonna return a true. Otherwise, if this is true and this is false, always false. And if this is false, this is true, always. Let's kind of try this. A is equal to 30. It's gonna return a true. But as soon as I let's say enter 60, it will return false. Let's make it a bit more easy. True and true. So if two true, it's always gonna return true. And if one false, false, it's gonna return false. And if the other one is false, it's always false. So the basic idea is if both are true, then it's gonna return true. It's and operator. And if we talk about or operator, it's kind of something like this. It's like if he founds one true, it's gonna return a true. Or yeah, or operator. So as you can see, it found, like, we can maybe encapsulate this thing to make it more organized. So as you can see, if there is one true, it's gonna return true, no matter like what is the, we can even enter true here. So it's like if it found a true, it's gonna return true. But in this case, if it founds a false, it's gonna return a false. So that's basically the thing. And yeah, not operator, I guess not. It will just return the opposite of what we are giving. Let's suppose we were checking if a is equals to 10, and before that we just what a is equals to 10, so we're just checking and we said a is 20. So it will return true because we used a not operator. And if we will not use this not operator, we will get a true. But in some cases, if we have a true condition, let's suppose if a user is logged in, so we don't need to ask him to again log in, so we will just use a not operator if the user is logged in. So that specific function or statement will not run. And as soon as the user is not logged in, it will return a true. And oh, it will return a false, that no, the user is not logged in, and we gonna use not to convert that into true and run that specific function. So this might be one of the use case of these logical operators. And identity operator, it's kind of similar to equals to and not equals to. Let's just discuss that. Is uh, 4 is 5. Let's see. Oh my god. False. And maybe we need to store that. Is equals to 4 and b is equals to 6. If I can do is something like this. Oh yeah, we need to store them in variables. So it just checks like
yeah.
if one thing is the other thing. We are just, in short, we are just doing this. It will also return the same. So that's another way to do that. Is this or is not this, or we can use is not also, if I'm not wrong. So yeah, a is not b, that's true. Yeah, a is 4 and b is 6, so it's not like that. So yeah, sometimes we use is or not, but I kind of prefer equal to a is equals to b, or a is not equals to
Not
b.
equal to. Yeah.
Yeah, yeah, this is more, I don't know, clean organized instead of is and is not, but they do the same work. Return true if both variables are not the same object. Yeah, something like that. Okay, Python membership operator. Oh, in. I guess we discussed this in last session in when we were discussing strings. So let's suppose we have a string a is equals to city, and we are checking is I present in A, like is I in A, and it will say true because I is there.
So,
City has a I, so we can use this. Like if we have a list or a dictionary, we could just use in object to check that if that is there, or something like that. Yep. Come on.
got it.
Yep. That was kind of really easy. And or action or this, I don't know. We just discussed set each bitwise operator is used to compare binary numbers. So we are not playing with binary numbers, so I don't think so we need to discuss it. But it's same, the rules are same, but here we just
Mm.
can compare like 0 and 1. This is for binary numbers, 0 and 1, only two numbers. And the same, if both are 1, then it's gonna return true. If in our case, if 1 is true, it's gonna return true. XNOR, bit to 1, I don't know, but not is like it will kind of reverse that thing. I don't know, we really don't use that except and, or, and not. But this is like the symbols are specifically for bitwise operators like binary, but in general case we just use these one and or not, like for to compare our, play with our data structures, Python data structures. Okay, so Boolean is kind of done, operator is done. Let's move to list. That's kind of a good part. Like, I guess you have an idea about Python
Yeah,
list.
we did lists last week, actually.
Oh, we did list last
With,
week?
with yes, and tuples.
Oh, really?
Yeah.
Like, but did we talk about
Remember?
Boolean and that stuff? I guess we forgot that. Okay. So,
Yeah.
yeah, like, did we
When you
also
were saying
discuss?
that lists are mutable, tuples are not mutable.
Yeah, exactly. So,
Yeah,
today
you
we can
remember
discuss about.
we talked last week.
Yeah. We did that. But like today we can discuss about some method related to list.
Okay,
Like,
that's
yeah,
fine.
the method or the function that are kind of linked to list. And oh yeah, I guess you know about this. You know how to get the value from first index using square notation.
Yeah. Indexing.
It will get banana because list
Yeah,
index start from 0. So -1 would start from the last thing, last value,
yeah,
and this is basically slicing. Start from 0, 1, 2, and 3, 4, and on 4, and just before 5. So basically it's 4.
yeah,
So next thing is from starting up till 4, and
yeah,
from
yeah.
2 up till end. Like if
Two
there's
until
nothing.
the end. Yeah,
Yeah, exactly. It's same, starting from -1, 2, 3, 4. It will start from -4 and go up
yeah,
till -1. Just before -1, not -1. So it will be -2. And if apple is present in this, we just saw the like in. So we can use like apple in this, and let's just skip this if statement. We gonna discuss this later. So it's just doing that. It's returning, basically it's returning true, and if there is a true if statement, will say okay, now go in my body and run this statement, so it will just print this out. And if apple is not present in this if statement, will not allow the interpreter to go inside its body and run the statements inside if body. So yeah, let's see what else we have. Change item. Oh, I guess we also saw this. Go on
yeah.
index
We
1
did
and
discuss.
change
Yeah,
this. Oh, we can also give a slice that from 1 to 3, change
yeah,
this to this. It's kind of same. It's not kind of same. It will change the second value by replacing it with two new values. Okay. So yeah, it's quite interesting. It's like go here as you know, it starts from the exact number but ends a number,
before.
yeah, before.
Yeah.
So it will go here and add like two values on this place. So that's maybe could be a new thing for you. Like we can even add more than two, three values on a particular index or something. Sim goes here and insert. Like, did we? Uh, oh, well, let's discuss this insert function. Uh, list list methods, and then we can just say insert. Oops. Okay. So let's suppose we have a list and we want to, like you had a question last time and I told you we can use insert. Like I was telling you we can push and pop like the atoms. Like if I do this list dot what was that? I forgot that. Maybe pop. Yeah, pop to, like, pop out the last element from the list. And if I run this cherry will get popped out and our new list will be you know will not have the last element. And you had a question that, like, if we want to insert on a specific index, actually, yeah. So we have another method insert. We just give the index. Maybe we can insert an index 1 and this would be the value new. So yeah, here we go. We can insert a specific value on a specific index. So that's a good method to remember about the lists. And yeah, let's move forward. Add list items. Append. Yeah, append. Just, I guess you remember this
Yeah.
append. Yeah,
Yeah. Yeah.
adding the, yeah, a new element at the last of the list or the end of the list. Insert is basically doing the same thing but on a specific index. Extend. Oh, extend is like we have two lists and we want to join them. So let's
Mm.
try this and see what exactly this is.
So
Yeah, like we have two different lists. Let's suppose we have a student from class 1 and class 2, but now, like, the principal said that just merge these two classes, so we can use extend method. uh, but the thing is we need to say, okay, this list dot extend, and then we need to enter the second list. Let's rename this into first and let's rename this into second. So first dot extend, and then inside that we need to pass
yeah.
this second. And the important thing to know is the second would stay the same, but the first list, it will get up, like, extended. Let me show you how it really looks like. This is the first one, and if I print the second one, it's gonna be the same. So basically what we did, that's where it's like something like, the thing is we used extend function on the first list. Like if we had used that on second list, like if we have written like second here and first here, then it would be a bit different. Like, let's see what it is really. So second is kind of extended, but the element of seconds are coming here, and after that we are getting the element of the
Yeah.
first
First.
list.
Yeah.
Yeah.
But couldn't we have concatenated the first and the second list?
Yeah, we can do this, I guess, but for that, let's try that. For not this second dot count copy count. We don't have a concatenation method on list. That's on
Okay. Okay.
numpy
Okay.
arrays actually.
Okay. All right. All right.
On this list, like, you can see, like, we only have these much. Oh, these, we have a lot of them. So count, clear, append, copy, extend, insert, index, pop, remove, reverse, sort.
Remove, reverse, sort.
Uh, yeah, that's oh, we again have some of them. Append, clear, copy, count. Oh, they are same. Reverse sort. So that's what we have for list. We discussed pop, insert, and we discussed append and extend, and we can make a copy by using a copy, and then we need to do this, and we can store in like copy second, like we can just make a copy of our list. And well, like we could have done something like this, like a is equals to second, and a would have looked like second if I print a and second on the same line. Like, see, they both are a is this and b is this, but as soon as I change something in a, this is basically just a reflection of second in a. That's a is not a copy of second or something like this. A just contains the reflection of second. Anything changed in a would reflect in second, and anything changed in second would reflect in a. Let's kind of try that. Second dot append. Let's append triple T in that, and let's try to again run this cell. Like, see here, triple T is present in both of them, and
Both.
same goes for A. If I append something in A, let's about triple G, tetra G, and you would notice that it gets appended in both of them. So that's like if someone is new in Python, they would have thought that it's creating a new variable, so this is kind of separate thing and this is separate, but these both are just reflection of each other. That's what is different. When we use copy, it creates a copy and sends to this, and now this is a completely new different thing. We can do anything, and that will only stay in this. It will not affect this original list, second list.
Got it.
And let's see more of them, like append copy clear. I guess clear is to completely clear the list, like delete everything from the second. And let's see if it did. Yeah, now it's empty. We deleted that. Instead of we had a del option. Let's again, where did we, yeah, let's do this, and we had an option of del. We are like del second, and we just give the index. Delete the third papaya from the second. And if I run this, and if I again run this second, it deletes that papaya. But what this clear does, it's completely deletes everything. We could do this by like, but we need to explicitly give index of each value. But we have this clear, which can be a good thing. And count, let's see what it is. I guess it returns the number of occurrence of a value. So let's suppose in this second list we have let's append and add another apple, and second dot append, let's add a banana to it, and now run this. And now let's suppose we have a huge list, and we want to append something, and we want to check that how many times a specific value is coming in that list. So we can use count and just pass that value, and it will return the number of times that value appears in that list. So yeah, count method. Let's see for other method, count and dot index. It does the same. We need to pass a specific value, and it will return the index of that value. But here you could see, like we have like two values which are apple. But what this
Yeah.
index method does, it's kind of starts scanning from the beginning, and as soon as it finds this desired results, it's kind of stop. It does not goes further and try to search like if there is another apple or something. It just returns the first index. It just returns the first index of the first occurrence.
Got it.
Cool. Basically, we don't really need to memorize this, as if you're using a smart ID, you just need to enter this and put a dot, and after that the ID pops up with some like this hints
Function.
or suggestions. Yeah, these are just suggestions what you really want to do after dot. So Python is just, as I told you, it kind of explains index, find the index, extend to list, count a value, make a copy, clear, and what else we had? Append, clear, copy, count, extend, index, sort.
Index.
Sort the list from 1 to 0
Yeah,
or 10 to something like this. So that's
yeah,
not a
yeah.
really big deal, but we should know that, yeah, there was something in the list that had, like, there was a method that can do this and this. So that's the thing to remember.
Good.
And yeah, the another thing to remember was this, index, like, what result would it give? Like, if you are in a search of specific indexes, but the thing to remember is it will only return the first occurrence index.
Mm.
Let's see if we covered all. Removing, looping list, remove list item. Yeah, we did looping. We're gonna see that later. List comprehension. That's also a advanced concept. Sort, yeah. Copy, join, yep.